dear students. Welcome to Study of Science. In this session, I am going to teach you how to write the structural and the molecular formula for the functional group alcohol. Here I have some of the examples which comes under the group alcohol. They are the methanol, ethanol, propanol, butanol, pentanol. It continues. Hexanol, heptanol, octanol. It continues. Okay. So for these first 5 members, I am going to teach you how to write the molecular formula as well as the structural formula. By following this, you can write any other member which comes under the functional group alcohol. Then let's get started. See, methanol. We know that meth means there is 1 carbon. Eth means 2 carbons. Prop means 3 carbon. But means 4 and pent means 5. So this carbon also includes the carbon if it is present in the functional group. That means if the functional group contains the carbon, that carbon is also included for the longest carbon chain. Whereas our functional group here is the alcohol. So the suffix is OH. So in OH, we do not have any carbon atom. Clear? So now, as I told you in the previous session that when we are writing the naming for the alcohol group, then no need to worry about the carbon atom in the longest carbon chain. Okay. So methanol. See, methanol. Here methane. Methane means it is methane. For methane, we are going to add oil. See, if before adding this oil, this methane loses 1 hydrogen. It becomes methyl. Right? For methyl group, we are going to add oil. So what is methane? What is the formula of methane? Formula for methane is CH4. Right? So formula for methane is CH4. So as we are removing 1 hydrogen from the methane, it becomes CH3. It becomes CH3. And for this CH3, we are adding up the alcohol group. So as I told you in the name, it is OL, whereas in the molecular formula, the suffix will be OH. It is OH. So now the molecular formula for the methanol is CH3OH. The molecular formula is CH3OH. Now I will teach you how to write the structural formula for the methanol. What do we have? We have CH3. That means 1 carbon atom is bonded with 3 hydrogen atom. This is CH3. And what is a functional group? The suffix is OH. See, in the structural formula, the functional group is represented by OH. This is how we write the structural formula for the methanol. Okay. So as I told you that from the methane, we are removing 1 hydrogen, it becomes methyl. For this methyl, we are adding the OH, that is the suffix. So this OH is the functional group alcohol. Okay. So by looking at the molecular formula, we can write easily the structural formula. Very easy, right? So now moving towards the next one, that is ethanol. What is the molecular formula for ethane? Molecular formula for ethane is C2H6. Correct? So from ethane, now we are going to remove 1 hydrogen. So it becomes C2H5. So ethane became ethyl now. For this ethyl, we are going to add the functional group. What is the functional group? All. That is, all is OH. All. In the name it is OL, but in the molecular formula it is OH. So the molecular formula for ethanol is C2H5OH. It is C2H5OH. So now, moving towards the structural formula, how many carbon atoms are here? 2. So C2. 2 carbon atoms. Okay. Single bond between the carbon and carbon atom. How many hydrogen? 5. 1, 2, 3, 4, 5. And our functional group is OH. Okay. So now the remaining places in this longest carbon chain has to be filled by the hydrogen. This is how we write the structural formula for ethanol. Structural formula for ethanol. Very easy. If you know the molecular formula of the ethane, you can write ethanol by adding OH to it, right? So by looking at the molecular formula, it is very easy to write the structural formula. So moving towards the propanol. What is the molecular formula for propane? Prop means 3. It is C3H8. It is C3H8. So by removing one hydrogen, we get C3H7. Correct? So propane became propyl. For this propyl, we are going to add now the functional group. Which is the functional group here? OL. So I have added OH. I have added OH. Now this is our molecular formula for the propanol. Molecular formula for propanol is C3H7OH. By looking at this, very easy to write the structural formula. C3. So 1, 2, 3. 3 carbon atom. Single bond between the carbon atom. How many hydrogen? 7. 1, 2, 3, 4, 5, 6 and 7. And finally, we are going to attach the functional group OH, that is alcohol. Remaining places in the longest carbon chain will be filled by the hydrogen. Clear? Very simple, right? So this is how we write the structural formula for the propanol. Propane means 3 carbon. Propane is 3 carbon. The molecular formula for propane is C3H8. By removing one hydrogen, we got C3H7. For this, we are going to add the functional group, that is OH. OL means OH. By looking at the molecular formula, very easy to write the structural formula. So now let us move towards the next one, that is bute. Bute means there are 4 carbon atoms. So it is butane now. So C4H10 is butane. C4H10 is butane. So now by removing one hydrogen, it becomes C4H9. So butane became butyl. Butane became butyl. For this, we are going to add our functional group. OL means it is again OH. OL means OH. So now the molecular formula for the butanol is C4H9OH. C4H9OH is the molecular formula for butanol. So coming to the structural formula, by looking at the molecular formula, very easy. C4 means 4 carbon atom. 1, 2, 3, 4 carbon atom. Right? Single bond between the carbon and carbon atom. How many hydrogen? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And moving towards the functional group, we have to write at the end. So remaining part of the carbon in the longest carbon chain will be filled by the hydrogen. So it is filled by the hydrogen. Clear? It's very simple, right? By looking at the molecular formula, we are going to write the structural formula. So moving to the next, that is pentanol. Pent means 5. Pentane means C5H12. Pentane is C5H12. So now by removing one hydrogen, it becomes C5H11. So for this alkyl group, we are going to add the functional group OH. OL means OH. So C5H11OH is the molecular formula for pentanol. The molecular formula for pentanol is C5H11OH. Clear? Now by looking at this molecular formula, we have to write the structural formula C5. That means 1, 2, 3, 4, 5, H11. So before writing the hydrogen, let us write the single bond between the carbon and carbon atom. So now hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And finally OH is the functional group which has to be attached. So the remaining places in the longest carbon chain has to be filled by the hydrogen. It has to be filled by the hydrogen. Very easy. Okay, this is how we write the structural formula for pentanol. Okay, so for example, if in the examination, if they ask you to write the molecular formula by giving the structural formula, very easy children, just look at the structure. See, look at the structure. If you look at the structure, you can find that CH3, CH2. See, it is CH3. Look at here, it is CH3 and here it is CH2. CH3, CH2. Don't disturb, never disturb the functional group. You never disturb the functional group and write as it is. CH3, CH2OH. So now you can add the number of carbon atom as well as number of hydrogen atom. C1 and C1, that is 1 plus 1, it is 2. C2. H3 plus 2 is 5. C2H5. And as I told you, don't disturb the functional group, write as it is. Observe here. See the formula which we have got here, C2H5OH, and here also it is C2H5OH. If in examination, if they give the structural formula and ask you to write the molecular formula, use this very simple trick. Look at the longest carbon chain. See, for example, as I have told you here, it is having one carbon atom bonded by 3 hydrogen. Here one carbon atom bonded by 2 hydrogen. So it is CH3, CH2, and I don't disturb the functional group, write as it is, so it is easy for you to write the molecular formula. One more example I can give you to understand better. See, let us take the last one. So it is the longest carbon chain, so it is easy for you to understand. For example, in the examination, if they give the longest carbon chain and ask you to write the molecular formula of this functional group, look at the longest carbon chain. Okay, by looking at this, CH3, it is CH3, again CH2, CH2, again CH2, write as it is, CH2, write as it is, again CH2, write as it is, and don't disturb the functional group, write as it is. See, CH3, CH2, 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 OH. Now, it's time to add all the carbon atoms without disturbing our functional group. So, the number of carbon atoms are 1, 2, 3, 4, 5. So, it is C5. Okay. How many hydrogen atoms are there? H3. 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. 9 plus 2, 11. H11. And as I told you, we are not disturbing the functional group, right, as it is. Now, cross-verify. The formula which you have got here is C5H11OH, and it is same as the molecular formula we have written at the first. Okay. So, this is how you can write the molecular formula by looking at the structural formula. Suppose if they give name, write the number of carbon atoms, write the alkane group, remove one hydrogen, make it as alkyl, add the functional group, and then write structure. Suppose if they give structure, write the molecular formula in this very simple method. I hope I made very easy to understand the functional group alcohol. It is very easy to write the structural formula as well as the molecular formula if you follow this method. If you find this video is useful, kindly share with your friends. And if you have not subscribed to my channel, kindly subscribe to my channel and don't forget to hit the bell notification to receive all the new videos which I upload. That's all for this session. I'm signing off. Thank you.